Hello everyone, I'm Oliveira, I work at Castro company and I'm going to talk a little about our project, development of a new solar dryer for thermal food processing. Castro is a Portuguese company that develops, produces and integrates products in the areas of air conditioning and the environment, using the best technology available in order to make them as efficient and environmentally friendly as possible. We are developing a new solar dryer for thermal processing dehydration food. Drying is a mass transfer process whereby moisture from a material is evaporated and removed from its surface by means of a carrier gas that passes through or over the material. In agri-food products, this process is often used as a preservation method. It allows the stabilizing of the microbiological activity and reducing the chemical and enzymatic reactions due to decreased water activity. Increase the durability of the product through the year and reducing the product weight, reducing the transport and storage costs. Solar drying is one of the oldest techniques used by men to preserve food. As drying is an energy-intensive process that consumes around 15% of all energy in the agri-food industry, the use of solar energy continues to be of special interest today. This project was dedicated to development of a solar dryer prototype by us and aimed to define strategies for its optimization in terms of productivity, quality of the dried product, energy consumption and production costs. The prototype, in its current version, was instrumented and tested under real operating conditions. For the test, several agri-food products and byproducts were used: spinach, lettuce, kale and apple pomace. Castro Solar Dryer is innovative both in its form and its content, with a new drying chamber in which one of its walls is formed by an absorbing surface with very high performance. This chamber does not receive any incidence of sunlight so that ultraviolet radiation does not damage the characteristics of the product to be dehydrated. The hot air inlet fans coming from the observer surface, recirculation and extraction fans are properly controlled and powered by photovoltaic energy. The hot air inlet fan may stop as soon as the set point temperature is reached in drying chamber, as well as defined relative humidity after a determined time, this time defined according to each product to be treated. The recirculation fan works with the objective of accelerating the drying process, creating a maelstrom of air inside the drying chamber to uniform the temperature and relative humidity inside it. The extraction fan will come on whenever there is a temperature higher than the desired one and to help extract moisture from inside the drying chamber. The absorbing material we are using is the same as that used in solar thermal collectors for heating sanitary water, already with numerous proofs of its high efficiency. As this material is very sensitive to the surrounding environment, it was necessary to create an air chamber with tempered glass and insulate metallic coating, thus promoting air circulation in this chamber where the air will be heated. The drying chamber is built in a material that guarantees insulation so that a constant temperature can be maintained inside it. The drying chamber is built in a material that guarantees insulation so that a constant temperature can be maintained inside it. For monitoring the temperature and relative humidity conditions in the Chatron solar dryer, we have developed the system that allows reading and recording of various temperature and relative humidity probes, as well being remotely assessed for greater process control without the need to travel to the location where are implemented Chatron solar dryer. A system of maintenance and predictive action was also implemented which, depending on meteorological data, the location of solar dryer, other factors and electronic sensing, the command and control system is prepared to obtain data from the environment in a precise way, predict the best time for drying in a given period of time. As the weather conditions vary over the 24 hours and there is a need for a continuous drying process, it is necessary to have a system that complements the sun. Here, the Chatron solar dryer allows interconnection to the system that is available on local. It can be heat pump system, a system using biomass, making use of the waste that may exist on the local, thus contributing to the circular economy and sustainable. The advantages of the solar Chatron dryer are numerous for increasing the shelf life of the products and reducing post-harvest losses, obtaining products of superior quality and greater added value to the product, reduction of product transportation and storage costs, greater efficiency compared to conventional electric or fuel drying, no dependence on fuels, easy maintenance system and integration with complementary systems, greater hygiene compared to drying in the sun, total control over the entire process and possibility of forecasting delivery of dry product, which translate into an economic advantage and customer loyalty. From all the tests carried out, measurements, analysis and readings of drying curves, it can be concluded that the products resulting from drying in a Chatron solar dryer maintain their sensory, visual and organoleptic characteristics. It is also verified that there is a reduction of around 35% in energy consumption compared to conventional systems. Our next objective will be to build a solar dehydrator that will allow us to achieve a 45% reduction in energy consumption with a product with low acquisition and maintenance cost.